Okay, so 1301. Now, differential equation, that's what we're doing. It's pretty much, you know, the differential equation is gradient. And because of this dy dx, that solutions, it's going to be is the original equation with different possible constants. So we are not going to get just one graph, original graph anymore. We're going to have a, you know, various different positions. And we are, because dy dx is gradient, we are using directions, you know, positive direction, negative directions, something like that. Okay. And because we are not getting just one particular equation and graph, and there's lots of possible constants, so you're going to get direction field. So to find the original function, obviously we have to use integration. Okay, so on the second line there, it says by finding the integral or antiderivative. Okay, so we're going to have to use that. And also because of that, and there's no limits, specific range, so we're going to have a constant. Okay, could be any constant because we don't know. Solve. Okay, now when it says solve, it means just find the original function. That's all. So we probably have to do, what we have to do is integration, right? So dy dx, and I'm going to find y equals. So integration 6x squared minus 4x. Now, while you're watching it, you could do it as well. Oops, in your book. So what will happen, because we don't have a limit, we'll have definitely have a c at the end, but luckily we have this points there, x and y values there. So what's happening here is what? 6x power cube 3 minus 4x squared over 2 plus 3x. So I'm going to just okay, that's not too bad. And I'm going to substitute in, okay, at 1 and 5. Okay, so 5 goes here, 2, 1, 2, 3. And if you just use the calculation, you will probably get 2. So therefore, I could use different color. It'll be y equals 2x cubed minus 2x squared plus 3x plus 2. Are we okay with that? Okay, so that's what it is. So when you see the word solve, you just need to do integration and find the original equation. That's all. Okay, so we're going to the next one. Before you do anything, just have a guess. What will be, this is like a parabola, isn't it? If this is a dy dx, it's parabola, what will be y? It's one more power, isn't it? So we'll get cubic, right? We'll get cubic. What I've got here, so what's happening here is I'm going to pretend like that graph that we saw is something like that, and I'm going to make it look like something like that, but not exactly. Put it up there, plus 2. So can you see what I've done? So that looks like what we've done, right? That I'm going to put it down. It looks like on the example graph, roughly. And I just want to show you that's where it's going to go, because I thought it's moving to its concave down. So I'm going to put the negative, and I'll say it's going to moving to the right because it's not actually symmetrical about the y-axis. So I just shift it by 1. And then I moved it up by 2. You could do 3, could do 1. So that I will have 2 x-intercepts here. So roughly I've done this just to show you. And then what happens if I integrate these, and I will get something like that. And if I change the constant to -1, that's a green one, okay, it's still on the same line of that. You know, can you see the shape is still similar, but it's moved down and up. And if I make changes with constant, it will see something like constant values, because we haven't given it just one constant value. So we could have a family of the solutions here. Okay, family of solution here. So that's what we are going to do. All right. Now that's because from here, we are going to use direction fields, okay, using the gradients. All right. So let's have a look. Before we start, I want you to have a look at this. Now, this is just parabolas, right? And I'm looking at when x equals 1. So when I look at x equals 1, I just already put the little dots there, right here, and right here, and right here. I just want to see the gradient at this point, that's all. So when the gradient gets bigger, because the red one is the smallest because it's 1, blue one is 3, green one is a 6. So I just sketched my gradient for at x equals 1. Can you see the difference here? So the more, well, the bigger the actually value, gradient value, okay, the steeper the actual graph will be, okay? So in reverse, we could say the smaller the gradient values, the graph will be flattened out. So if it's a steeper, meaning it's going like a vertically, and the flattening out as like horizontally. So keep that in mind because we need to use that idea, okay? At the moment, I made it into vertical in this example because it's getting bigger. But if it gets smaller, say my gradient is like half or 3/4 or something like that, my gradient will be flattening out horizontally, okay? So keep that in mind because we are going to use that for direction fields. So example 2. So we got draw the direction field for dy dx equals 3x. And then we need to find the graph of that at 0, 1. Okay, so I got this. First thing you need to do, we need to think about sort of like a plotting it. It's not really plotting of points, but we are sort of plotting the gradients. So I will use a table, okay? So just very basic 2 tables, x values here, and dy dx equals 3x. So I want to see what will happen when the x value is changing it. So I'll go with a 0 to start with, and then I'll put 1, and I'll put -1. I want to see what happens. And then I will put 2, and then I'll finish that off. Okay, 0. If I put 0, I will get 0. Now, what does that mean when the gradient is 0? It's stationary point, isn't it? Something like this or like that. And that point is where, like this part and that part, is where the gradient should be on the, yep. So, and when I put the 1 in there, it'll be 3, it'll be -3, 6, and it'll be -6, and so on. Okay. So how do we show it on the number plane here? I will actually show you here. So when it's a 0, when x equals 0, that's the y-axis, its gradient is 0. So it's going to be flat, right? Because it's a stationary point. So it's going to be flat. And then 1 is 3. And then when you look at a 2, it's 6. So it's not as steep as 6, but it'll be roughly. So I'm going to go with something like that. When it's 1, like that. Okay. And you can actually do that at the same, roughly, because their gradient will be the same here. And -1 is a -3. So they're same sort of value, but the different direction. So what I'm going to do is like this. Okay, that's all right. So it's like sort of like reflecting. And then 2 is, it's steeper than 1. So just be careful. Let's see if I can do that. So a little bit steeper than, oops, before. And eventually, next one will be like almost like vertical. Like, you know what I mean? Vertical. And then eventually it will go like almost like vertical. And it'll be the same on the second quadrant. If I did that, what will happen? It'll be look like this. Okay, so can you see what I've done there? So all those, it looks like it is direction field, plotting small part of gradients, okay, of the function, okay, differential function. So B, we need to find the graph of the function with the dy dx equals 3x, given that it passes through 0 and 1. So I just put the dot there, 0 and 1. That's what the question asks us to do. Now, this is a little bit tricky, you know, and then you have to follow the gradient and then sketch it. And you might say, how do we know, Miss, that it's going to end up here or there? They will say, roughly, you can sketch it. But what I would say is, well, why don't we just do it using calculus? Do that first, and then maybe sketch it as well. So what I'm going to do is, you know, there is that C first, y equals 3x squared over 2 plus c. Okay, and then it was at 0 and 1. And then when you substitute in 1, 0 plus c, so your c is 1. So roughly, right, I'm just going to put that c here. And so y equals 3 over 2x squared plus 1. Okay, so, and then if it was, this is what we are trying to do. So if I put 2 here at x equals 2, y will be, so it'll be 6 and 7, isn't it? Yeah. So it's roughly 2 is 7 up here somewhere. Okay. So I know that it's probably going through here. Okay. So my sketch here is my stationary, so it's a curved, and aiming for going here. Aiming for going here. So, you know, like sometimes they, you know, find the intersection point by graphing or use graph, but in the exam, you probably do it algebraically, find the sort of, you know, intersection point, and then you probably sketch it around it. You know what I mean? So that's what I've done, because sometimes you don't know how far it's going to go, sort of, you know. So I've done that first, and then I'll go roughly. So your answer for part C is just here, and then this part is just think of as it happens in your head. And that's what I've done, and then that's what it is here. Okay, so roughly there. And then example 3, draw a direction field for dy dx equals 1 over x squared. Now, just think about this. When you integrate this, what are you getting? I see hyperbola, because it's going to be 1 over x, because it's going to be x to the negative, or negative x to the power of -1. So I'm just going to think about that. You don't have to do it, but just, you know, predict. You know, prediction is math, really. So I'm going to think about this. One thing you need to think about here is x cannot be 0. So we're going to have asymptote here. So I'm going to draw the direction field. And to do that, I'm going to use table. Okay. I think table is the simplest and the easiest way to do this. So I'm going to sketch just 2 parts. That's all. That's all I'm going to do, just like what we did before. So I'm just going to go x dy dx equals 1 over x squared. And I'm going to go with a 0. I know it can't be 0, so I'm just going to put infinity there. 1 minus 1, because I want to see what happens to the other side. So when I put 1 is 1, minus 1 still 1, 1 over 4, 1 over 4. Okay, so if you look at it, what have you noticed here? Whatever the x value, the y, what dy dx will be the same, isn't it? Well, just call this m, not y. Otherwise, you get confused, isn't it? Because dy dx is gradient, so I'm going to call it m. M equals same. Now, what does that mean if it's the same? Because it's something to do with the direction, you know, so we've got to think of it as the same direction, okay? Whereas before, previous question, it was opposite direction, okay? Because the gradient was positive and the other was negative. So it's opposite. But this one, they're all positive and the same value, everything, okay? So it's almost like it's a reflection, like a mirror image. You know what I mean? So let's have a look. Now, we got a dotted line because it's my asymptote, because it cannot be 0, okay? So I've done that. Now, when it's 1 is 1, but if you compare to, this is a really good idea to comparing a next one, because we're getting smaller. What does that mean? It means it's going to go horizontal. It's flattening out. Eventually, it's going to flatten out like that, like that. And don't forget to do all the way, not just the 1 quadrant. And same thing here, isn't it? Because they're all the same direction. Whereas before, it was opposite. This one's the same, okay? And then the next one, it's getting smaller, so it's going to be flattened out. Let's see if I could do that. Not so good, but you know what I mean. I'm just going to do one side because the other side is exactly the same. So when you practice at home, make sure they are the same. And eventually, it'll be like that. This is what will happen, Okay, so if you don't take your time and, you know, do it really nicely, this will what will happen. Okay, they're all the same direction. Make sure you remember that. All right, so that was the direction field for dy dx equals 1 over x squared. And the next one, oops. Next one was we have to find the solution. Remember, solution is the y equals, okay? Y equals integrate x to the power of 2. I didn't have to do that. Dx. Okay, so I'm going to do that. X minus 1, because you're plus 1 minus 1 plus c. So my equation is something like that. All right, so that's good. So that's what I'm talking about. This is hyperbola, isn't it? So in my head, I'm just going to go that and that, right? So roughly, we are expecting something like that because it's a negative hyperbola. It's going to be second and fourth quadrant. Go to part C, which we got this from the previous one. So I'm going to think about, we know it's going to be, and the second quadrant and fourth quadrant. So it will be something like, it's going to be a bit tricky, but we know it's going to be something like, okay, my graphing is not that good, but you know what I mean. So don't worry about whether it's correct, because there are many different possible answers anyway. So getting to the closer to the asymptote, roughly, and that'll be really good idea. Okay, so this is what you're supposed to have. Okay, now that's all that is for this lesson. Any